All right, so welcome to day 2 of ellipses. Essentially what we're going to be doing today is going from a graph to an equation, so kind of the reverse of what we saw yesterday. There is an assignment posted on Google Classroom. It's a worksheet. It's the front and back. The front side of the worksheet is like the notes from yesterday. The back of the worksheet is kind of like the notes we're doing today. Um, Hopefully it's not too bad, but if you have questions, let me know. Maybe I can do a Zoom session later this week if people got questions. But these notes will be it for this week. So if you look at these notes, I already wrote out the horizontal ellipse and vertical ellipse formulas from yesterday, but just recall your A is always bigger than your B. So if your denominator under the X part's bigger, you're going to have an ellipse that's wider or horizontal, wider than it is tall. If your bigger denominator is under your Y part, you're going to have a vertical ellipse where it's taller than it is wide. Also, to recall from yesterday, remember A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. And to find the focus points, you use the formula c squared equals a squared minus b squared. So it's different than Pythagorean theorem, even though it kind of looks like that formula. So looking at some examples. So if they give you this ellipse, the first thing you just kind of want to, you don't need to necessarily write it down, but you definitely want to make a mental note. Is this a horizontal or a vertical ellipse? So looking at this one, it's horizontal because it's wider than it is tall. So we want to come up with our equation. So probably the first thing I'm going to do is just start finding, like I would start by just finding your center, your vertices, and your co-vertices. So your center, if you look right away, it's just 0, 0. Your vertices, remember your vertices are, if it's horizontal, your vertices are the points on the vertical axis, or sorry, the horizontal axis. So these will be our vertices. If you look at your points, you have one at 6, 0 and one at negative 6, 0. And your co-vertices would be on your vertical axis because it's the smaller one for a horizontal ellipse. So if you look, you have a point at 0, 4, and you have a point at 0, negative 4. So to get your equation, the first thing you want to kind of just use is your center. So I'm just going to kind of set up my general former. The equation is going to be a fraction plus a fraction equals 1. So that's kind of my general form. Since my center is 0, 0, I'm not going to have any, my h and k, I'm not going to have any junk on the top. So I'm really just going to have x squared by itself and y squared by itself. But in this formula, if you look, because it's a horizontal ellipse, we're going to have our a squared underneath our x squared and our b squared underneath our y squared. So your a, if you look, like this distance between the center and the vertex was 6, and the distance from the center to our co-vertice was 4. So since the bigger one's your a, you have a equals 6 and you have b equals 4. And since it's a squared and b squared, you just square these. So our a squared would be 36. And your b squared would be 16. So that would go underneath your y. And you always put your, like, since it's a horizontal ellipse, you put the bigger one underneath your x, the smaller one under your y. If it was a vertical ellipse, these would be flip-flopped. So my equation would just be x squared over 36 plus y squared over 16 equals 1. To get our focus points, we just use this formula here. So c squared, and since my a squared, I know what my a squared and my b squared are, so it'd be 36 minus 16. So that's 20. So c squared equals 20. So you would just square root 20. So c is approximately 4.47 if you put that in a calculator. So our focus points, you remember you just add this to your center, and since it's a horizontal, you add it to the x value. So it would be 4.470, and it would be negative 4.470. So that's the equation of this ellipse. That's kind of the idea. To be honest with you, the focus points, like I said from yesterday, it's not my big focus. I'm more worried, can you pull out your vertices, co-vertices, and just get that equation? The focus points, like I said, we're really not doing too much with them, but if you are in a future class, you might do more applications with the focus points, depending on what you're doing. So let's look at example 2. Looking at this one, you can see this is a vertical ellipse. So the first thing I would do is just find your information about your ellipse. So your center, once again, is 0, 0. Right, please. Sloppy, but yeah, your center is 0, 0. Your vertices, since it's a vertical ellipse, would be these points, because that's on your major axis. So if you look at those, it's 0, 7. My stylus is breaking. Okay, I think I fixed it. Let's see, 0, 7, 0, negative 7. And your co-vertices would be on your minor axis. So it'd be 0, or sorry, not 0, 3, 0, and negative 3, 0. So now we have everything we need to pretty much start writing our equation. Like if you look, your A's from your center to here, so this would be 7. And your B would be from here to here, which is 3. So your A is 7, your B is 3. So when you write your equation, it's going to be a fraction plus a fraction equals 1. So once again, since our center is 0, 0, you're just going to have x squared and y squared. Like nothing up top with them. The bottom, since it's vertical, you're going to put the a underneath your y value. So it would be 49, because a squared would be 49. And then your b squared would be 9. So since it's vertical, you put the bigger number squared underneath your y value. So you need to square them in that formula. So my equation would be x squared over 9 plus y squared over 49 equals 1. To find our focus points, we're just going to use that formula. So c squared equals a squared minus b squared, so that would be 49 minus 9, which would be 40. So if you square root that in a calculator, you get approximately 6.32. So if you so you add those to your major axis, so your focus points would be 0, 6.32, and then 0, negative 6.32. But to be honest with you, the focus points I'm not really worried about. If you want to even skip that on your assignment, just find the vertices, co-vertices, center, and equation. I don't necessarily care about this last step, to be honest with you. at least for what we're doing. Like I said, that you might do more applications with conic sections when you're doing these next year, but for the purpose of this class, I mean, we're pretty much just, my big focus is on, can you get a graph or can you get an equation of a given ellipse? That's more my focus. So looking at this last example on this page, we have an ellipse. It's a horizontal ellipse. So my center, if you look at your graph, your center is at 3, -6. So this time it's not 0, 0, so we'll see how that changes our equation. The vertices would be these points here and here. So I already went ahead and did this, but if you look at those points, the one on the right is 8, -6. The other point on the left would be -2, -6. Your covertices are these blue points. I went ahead and found the coordinates, but it's 3, -7, and it's 3, -5. And let's not worry about the focus points. You don't have to do that part on the assignment either. I'll add a note, but if you want to do them, you can. It's just using that formula. It's not like it's hard, but to be honest, we're not really doing anything with them, so it seems kind of, I don't really see a huge point for us to focus on them. No pun intended. But looking at this equation, it's going to be in this form: a fraction plus a fraction equals 1. Since we have a center that's not 0, 0, we're going to have stuff up top with our x and our y. So it's kind of like a circle. It's kind of opposite. So my x is going to be x minus 3 squared. My y part's going to be y plus 6 squared. If you look at our ellipse, the distance from the center to our vertice was, what was it? 5? 1, 2, 3, 4, 5, right? Yeah. So this distance is 5. Our distance from our center to a covertice was 1. So our A is 5. Our B is 1. So really A squared is 25. B squared would still just be 1. So remember, since it's a horizontal ellipse, we put the bigger number underneath the x. So the 25 would go here. And we put the smaller one then under our y value. So the 1 would go here. So our equation would be x minus 3 squared over 25 plus y plus 6 squared over 1 equals 1. So these are the type of problems you'll see on your assignment. You're not going to see any questions like on the back, so I might just do these as an enrichment. But to be honest with you, if you're trying to get help on your assignment, these are the examples you're going to want to look at: 1, 2, and 3. But basically, just find your center, your vertices, your covertices, and then just kind of use those pieces of information to get your equation. Like I said, if you don't want to find the focus points, don't worry. I mean, I'll put a note on the assignment that you don't have to do that. But it's up to you if you would like to. So we'll look at the next page. But like I said, these first 3 examples are what you're going to see on your assignment. But let's look at these on the back. It's pretty similar, except they just don't give you a picture. They give you some pieces of information. So, for example, this problem, they tell you the vertices and covertices, and they want you to write an equation. So one kind of trick we're going to use, if you think of like a picture, since this one, if you notice your vertices are bigger than your covertices, that means that since the vertices have an x value in them, this is going to be a horizontal because I notice these have x values. So this would be a horizontal ellipse. Like if you look at example 5, see how the vertices have a y value? This would be a vertical ellipse. But to get your equation, we have our vertices, we have our covertices. The problem is we need to figure out what our center is. But a neat little trick to get your center is looking at these points. Your center is always going to be the y value of your vertices and the x values of your covertices. Basically, the numbers that aren't the bigger of the two. Well, let me actually think. That's not always true, though. That's only if it's 0, 0. You really could do like a midpoint formula between the 2 points. Let me see. Let me make sure I'm understanding this key. Okay, so one way you could find your center, you could either look at your covertices or your vertices. It doesn't matter. If you find the middle between those two values, it's going to get your center. So you could just use midpoint formula. So like, for example, if I'm looking at my vertices, like if I do my x values added together, and I do my y values together, I'm just going to get, well, -5 plus 5 is 0. 0 plus 0 is 0. So my center is just going to be 0, 0. So now that I have all this info to get my equation, oops, remember, it's going to be a fraction plus a fraction equals 1. Well, since my center is 0, 0, that means I just have x squared and y squared. There's no nonsense going up top. To get your denominator, that's where you have to pull out your a and your b. So if you look at your vertices, that's where your a is going to come from. So since it's -5, that from your center, that would be 5. So your a would be 5. If you look at your covertices, it's -2 and 2. So your b value would be 2 away from your center. We'll see if your center's not 0, 0. You're gonna have to do a little bit more thinking. And since this is a horizontal ellipse, you put the a value underneath your x and the b value underneath your y. So remember, if you look at the original formula though, oops, that's not what I wanted to do. Remember, it's over a squared, it's over b squared. So you have to square your a and your b when you put it under the denominator. So for this problem, it would be 25 underneath the x part, and it would be 4 underneath our y part, because that's b squared, that's a squared. And you always put the bigger one underneath, depending on if it's horizontal or vertical. So since this one's horizontal, the x part has to be over the bigger denominator. So let's look at number 5, same idea. To find your center, you could do the midpoint of either the vertices or the covertices. So I'll just do the vertices. So if you do the x values, it would just be 0 plus 0 over 2, -8 plus 8 over 2, which once again, if you work that out, you're just still going to see you get 0, 0 for this one. So our equation is going to be a fraction plus a fraction equals 1. That's going to be kind of our general form. Since our center is 0, 0, there's no nonsense. So it's just x squared and y squared up top. If you look at our vertices, that's where you're going to get your a value. So it's 8 away from the center. If you plotted those points, your b, you look at your covertices, those would be 6 away from your center. Since this is a vertical ellipse, you're going to have to put the bigger number underneath your y value. So 8 squared would be 64. 6 squared would go underneath the x squared part. The stylus keeps falling apart. Oh, I need to mess with this. So the 36 would go underneath your other one. Let's see. Okay, and let's look at a couple more. I don't think I'm going to do all the problems on this page, to be honest, because like I said, you're not going to see any questions like this back page on your homework assignment, but I figured these might just be kind of helpful to kind of see how these work. But I want to at least do a couple more where your center is not 0, 0. So for example, number 6, if you find your center, you could look at your vertices or your co-vertices, it doesn't matter, but you just use the midpoint formula. Oops. So for example, if you add your x values and you add your y values, and if you simplify this, you're going to get -2, and you get 2 over 2 or just 1. So that's your center. So since we do have a center that's not 0, 0, we do have some extra nonsense, so we have to deal with that. So it's kind of like the opposite. So you would put x plus 2 squared, and then you would have y minus 1 squared. And then now we got to figure out what our a and b will be. Let me see if I can. So right now I have x plus 2 squared, I don't know my denominator, and I have y minus 1 squared, I don't know my denominator. So to get your a and your b where your center isn't 0, 0, you got to figure out how far was your vertices from your center and how far were your co-vertices from your center. So if you look at my vertices, for example, -5, 1, -2, 1, well, how far is -5, 1 from -2, 1? Well, it would be 3 away. Like your x value would be 3 away from the original. So my a would be 3. If you look at your co-vertices, to go from -2, 3 to -2, 1, well, how far apart are these 2 points? Like looking at these 2 points, how far is this point from this point? Well, the only thing that's different is the y value, and going from 1 to 3 or 3 to 1, that would just be 2 away. So that's our A and our B. So just make sure you're looking at your center if it's not 0, 0. Like how far away are your co-vertices or vertices away from it? Your vertices always give you your A value. Your co-vertices always give you your B value.
So for the co-vertices, you're looking at the y values?
It depends on the problem, but yes, just look at the center and the points and see what's different. Because what we're going to see in this problem is, well, first off, if you look at the vertices in the center, see how it's the x value that's different? That means this is actually going to be horizontal.
Mm-hmm.
Because the x's are what changes. If you look at the co-vertices, it's the y. Because your vertices always give you your a value, the co-vertices always are going to give you your b value. And since this is a horizontal ellipse, and the reason I knew it's horizontal is because, like I said, the vertices change the x values, not the y values. And that means when I write my equation, the bigger number has to go underneath the x part. So since my a is 3, when you put it in this formula, it's not just a, it's a squared. So I would put 9 underneath my x values. And then I put the smaller denominator underneath my y values since it's horizontal. So my b is 2, so that squared would be 4. So let's do one more of these, and I'll be honest, it's possible. Well, if you look at 8, 9, 10, and 11, they give you the focus points and not the co-vertices. Don't worry. I mean, it would just be some algebra. Don't worry about these questions. You won't have any on your assignment anyways. If you want to look, they are, like, I did post the notes key. I mean, you could look at like how they worked them out, but I'll be honest, I'm not really stressed if you know how to do that or not. So let's look at number 7, and then we'll call it a day. And maybe I'll kind of recap for people if you came in late, if you got questions. But number 7, they give us the vertices and the co-vertices. So the first thing we want to do is find our center. So you just need to do the midpoint either between your 2 vertice points or your co-vertices. It doesn't matter, because you think about an ellipse, between the vertex points is going to give you the center, or between the co-vertex points are going to give you the centers, like if you find the midpoint between them. So I'm just going to keep doing the vertices because that's what I've been doing, but I could also look at the co-vertice points. So I add my x values and I average them or divide by 2, and I add my y values and I divide by 2 or average them. So if you work this out, you're going to get 5, that'd be 2, so 1. So our center would be 5, 1. So I'm going to set up my equation. It's always a fraction plus a fraction equals 1. I guess the first thing we can do is our top now that we know our center. So since our center is not 0, 0, I'm going to have some extra stuff up top. So it's kind of like the opposite sign. So it'd be x minus 5 squared. And then it would be y minus 1 squared. So to get our denominators, the first thing we would kind of want to figure out, well, first off, do we have a horizontal or vertical ellipse? And then we need to figure out our a and our b value. So in this problem, I have my center. So I look at my vertices. See how like my first point is 5, 8. My center is 5, 1. So what changes? Is it your x values or your y values? Well, my y values changed from 5, 8 to 5, 1. So that means, first off, since the y values are changing, that's going to mean it's a vertical ellipse. And more importantly, to go from 5, 8 to 5, 1, well, you went down 7, or it's a distance of 7. So my a is going to be 7. We look at the covertices to get my b value. So if you look, it's 11, 1, 5, 1. So the x values are changing. Well, to go from 11 to 5, well, that would be a difference of 6, or a distance of 6. So my b is 6. So since this is a vertical ellipse, remember that means the bigger denominator has to go underneath your y value. So that would be my a squared, which would be 7 squared, or 49. And then my b squared would go underneath the x part then. So 6 squared would be 36. So that's kind of the idea. You use your center to get the top part of your equation. And then you kind of use your vertices to get your a value, your covertices to get your b value, which then you use to get your denominator. But the key idea is just remember, if it's a horizontal ellipse, you better have a bigger denominator underneath your x part. If it's a vertical ellipse, you better have a bigger denominator underneath your y part. Okay, so that's kind of the key kind of idea I'd say with these. So let me stop my recording.